So we have here this table, and we are given aluminium fluoride and also aluminium chloride. So obviously your aluminium chloride, you guys know, is the most famous chem bonding compound. And aluminium fluoride, maybe some of you might have seen it, some of you may not have seen it. Nonetheless, let's just look at the information that is given to us. We are given melting point. We are also given conductivity in molten state. Okay, so melting point, right, is very, very obvious that aluminium trifluoride has this very, very high melting point. Okay, so this should give you a very good hint what is the structure and bonding in aluminium trifluoride. And then you have your AlCl3, very low melting point. So that should also tell you, reinforce what you have learned before, that it is a simple molecular structure. Okay, then next we look at conductivity in molten state. Okay, if AlF3 can conduct, so it does mean that it is confirmed to be an ionic compound. So we just put it down here, which is quite congruent with what we know about the melting point. Okay, and then your aluminium chloride cannot conduct. Yes, it is confirmed to be a simple molecular structure. Okay, so how do you go about answering the question so that you can secure all 3 marks? Okay, so what is required here? Just look at the question here. They say explain the difference in melting point in terms of structure. There you have it. The first thing you need to tell the examiner, structure. What is the structure of AlF3? And what's the structure of AlCl3? Okay, so if you know these 2 things, let's just put them down. AlF3, giant ionic lattice structure, and AlCl3, simple molecular structure. So these are the things that we already know. We put them down, we score that first mark. Okay, so out of 3, you already got the first mark. Always remember, chem bonding question, a good 70% of them, you just need to put down the structure. Okay, just put down the structure and that's basically it. You score the first mark. Okay, then after that, you're supposed to explain, okay, why does it have a very high melting or boiling point? Okay, so here I think it's a melting point. So you need to use a large amount of energy to overcome what type of bonding? What type of bonding? Okay, so is to overcome strong electrostatic attraction between oppositely charged ions. Okay, I do recommend, right, this to take note of the important phrasing, large amount of energy, strong, okay, this is very important, strong electrostatic force of attraction between oppositely charged ion. Okay, so some schools really want you to put down the type of ions that is involved, Al3 plus, F minus. So might as well put it down, right? Okay, so some schools not as strict. They are okay with you just saying oppositely charged ions. Okay, so now we have explained for AlF3, we have scored the 2nd mark. The last mark basically is to explain for AlCl3. Okay, so AlCl3 melting point is minus 150. So you just need a small amount of energy to overcome ID. Okay, AlCl3 is non-polar. Okay, if you don't remember, it looks something like this. AlCl3. Okay, basic shape of trigonal planar. Okay, trigonal planar, it is non-polar, so it is ID. Alright, so our conclusion, melting point is much lower than aluminium trifluoride.